multi-step equations. And this really combines the simplifying expressions that we did in the first learning target and the solving two-step equation sorts of concepts that we did in the second learning target. The big difference is there will be times, and you can see this in some of these later problems, where one side of the equation has the distributive property that you could do, or in this case of D, I could do the distributive property and then I'm still going to have some like terms to combine. So what I'm going to do is I'm going to treat each side of the equation as its own simplification problem like we did in the first learning target. I'm going to keep my equal signs lined up. When I look at this left side of the equation, there are no like terms, there's no distributive property, so I don't need to simplify it. And then the same thing on the right side. No like terms, no distributive property, so I don't need to simplify it. And if you look, the same thing is true for B. So then I want to move my variable terms to one side of the equation, my terms with x, and every term that doesn't have x, in this case my constant terms, to the other side of the equation. So to do that, when I look at the right side of the equation, I have both a constant term and a variable term. Since I don't want them on the same side and I want my variable term to go to the left, I'm going to eliminate this minus 2x by adding 2x to both sides of the equation. Remember, you are not adding 2. Don't forget to put the x on it. This is going to give me 8x minus 8 equals 4. Then I want to get rid of this constant on the left side of the equation, so to eliminate a minus 8, I would add 8. And what I do to the left side of the equation, I also do to the right. So I have 8x equals 12. And last but not least, since this is 8 times x, I'm going to undo that multiplication by dividing by 8, which is going to give me 1x, and I just don't write the 1 coefficient, equals 1.5. Because that's an exact decimal that I didn't have to round, I'm allowed to give that answer as a decimal. Using the same sort of thought process in the second one, it doesn't matter whether I move my constant term or variable term first. So I might look at the left and say, well, I don't want this positive 6 on that side, that constant, so I'm going to subtract 6 to eliminate it on the left. Do the same thing to the right, and I would have positive, pay attention to what's in front of it, 4x equals 2 minus 4x. I don't want this variable term on the right side, so to eliminate a minus 4x, I would add 4x to both sides of the equation. And I would get 8x equals 2. And then finally, to undo this multiplying by 8 for the x, I would divide by 8 and divide the other side by 8. Again, it is acceptable to give a decimal in this case because it's exactly 0.25 and I didn't have to round it. Now by the time I get to the second set of problems, when I look at the left side of the equation, I see that there's a distributive property part to do. That should be done first. So 2.5 times 3, x is 7.5x, and then 2.5 times positive 4.8 is a positive 12. When I look at the right side of the equation, I can't simplify negative 35.25, so I'm just going to bring it down. Notice I'm keeping my equal signs lined up. I told you guys and showed you how you can get yourself in trouble sometimes if you don't do that. So a constant and a variable term on the left. Because there's a constant on the right, I want to move this constant to the right. To eliminate adding 12, I'm going to subtract 12. So 7.5x equals negative 47.25. Now don't forget that was a negative 35.25 to begin with. Some people are sort of losing those signs. And then the last thing I'm going to do to solve for x, divide by 7.5 because the x is being multiplied by 7.5. And when I take negative 47.25 and divide it by 7.5, I get 6.3, so negative 6.3. So x equals negative 6.3. Now notice, I did not draw the dashed line down through my equal signs. I don't have to because I actually keep them lined up from top to bottom. If you have a tendency to have that wandering equal sign, then putting the dashed line down through there would be helpful. When I look at the left side of the equation as its own simplification process, I see addition and subtraction, so I see subtraction here, but I remind myself there's multiplication between that 8 or negative 8 and the parentheses. So the first thing I'm going to do is distribute negative 8 to both of those terms. The 4x will come down because I'm not using it. Negative 8 times a positive 1x is a negative 8x, so I'm going to write minus 8x. Negative 8 times a negative 1 is a positive 8, so plus 8 equals the negative 8 on the other side. I'm still not done simplifying that left side of the equation, because on that side there's a 4x minus 8x, and 4x minus 8x is negative 4x, plus my 8 equals my negative 8. Again, I want to eliminate this plus 8 constant on the left, so I'm going to subtract 8 from both sides, which is going to give me negative 4x equals negative 16. Then when I divide both sides by negative 4, I get x equals positive 4. Again, looking at just the left side of the equation as its own simplification problem, I have some distributive property to do. I'm not going to do 2 minus 5 first, because I would never subtract in this case before I took care of this multiplication. So the 2 is going to come down. Negative 5 times 3x will make me write minus 15x here. Negative 5 times positive 4 is negative 20, so I'll write minus 20. Looking at the right side, I have a constant term and a variable term. No distributive property, no like terms to combine, so I'm just going to rewrite that side. I now have on the left side two constants that I can combine. So this is going to become negative 15x minus 18 equals 20 minus 13x. Move my x to the right, so to eliminate, or to my left, to eliminate a minus 13x, I would add 13x to both sides of the equation, which would give me negative 2x minus 18 equals 20. To eliminate the constant on the left, I would have to add 18 to both sides. Again, what I do to one side, I do to the other side. And I have negative 2x equals positive 38. And then when I divide both sides by negative 2 to undo this multiplying by negative 2, x equals negative 19. Now if I wanted to check that answer in my calculator and make sure that negative 19 is the right answer, I would put 2 minus 5. Some calculators require that you put times next before the parentheses. And then inside the parentheses, 3 times negative 19 plus 4, and I would hit equals to see what it equals. And on the other side, I'd punch in 20 minus 13 times negative 19 and hit equals and see what it equals. Now I'm going to do that really quickly. So 2 minus 5 times in parentheses 3 times negative 19 plus 4. I don't have to close the parentheses on my calculator because there's nothing that follows that. And I get 267 on that side of the equation. And then 20 minus 13 times negative 19 is also 267. So when I substitute negative 19 in for this x and calculate this side, and in for this x and calculate this side, they're both equal, which means that negative 19 is the solution to my equation.